In this section, I'm going to start on a series of tutorials based on the topic on mechanics. As you are all aware, mechanics is a branch in applied mathematics, and of course we apply it as well in physics, that it deals with the motion and forces that is producing those motion. So you'll find that mechanics is basically the study of moving objects. We are going to look at the motion, the movement of objects, as well as the forces that produce that motion. Now, because what we realize from this definition is the fact that we have got a force that produces motion. So we can't get into the study of motion without actually getting into the cause of that motion. That's why I've chosen to start with the forces. Why we need to study forces? Because forces are the biggest component of any motion. So in this tutorial, I'm going to start by defining force. What is a force? I will also cover the different kinds of force that we have, and that section is very important because for us to study the Newton's laws of motion, we need to identify the different kinds of force that we'll be working with in any motion of a moving object. So we'll cover the kinds of force. We have got two kinds of force: contact forces and also non-contact forces. And then we will also cover the free body diagram. So now there will be so much of writing in this section. So what I advise you is to get a pen and paper and write the definitions. There are many definitions in this section. So do the writing, and as well, if you see there's a need, pause the video and write down those definitions, because in the exam, most of the time they do ask you to define those terms. And most importantly, you must be able to understand the concept of that particular force. So first, we will cover force. What is a force? Because we need to know what is a force before we get into studying what is motion. So a force is any pull or push on an object in an attempt to change the object's state of rest or motion. Key terms here are that any push or any pull that we apply on an object constitute a force. And the purpose of a force is to change the object's rest. So we are implying that if an object is not moving and we are trying to push it or pull it, then it becomes a force. Or it may be moving, but then we push it further or we pull it back. So that force, that pulling or that pushing constitutes a force. So a force basically is any push or a pull on an object. We can have an object here, and on this object we are going to apply a force. When you apply a force, that force can be a pull or the force can be a push. So we have a pull here, or we can have a push there. So that pulling or pushing constitutes a force. The symbol that we use for force, we use the letter F, capital letter F, okay, to stand for force, of course, standing for force. Also, force is a quantity that we can measure. So we have got the standard unit that we use for force. The standard unit is the Newton. Okay, Later on, we will learn that 1 Newton is equivalent to 1 kilogram meter per second. In addition to that, we need also to understand that force is a vector. A vector is a quantity that has got a magnitude and direction. So when we specify a force, any particular force, we need to state the fact that there is a direction in which that particular force is acting, as well as we need to specify the magnitude, the size. Okay, it can be 10 Newton, 15 Newton, any size. Also, most cases we will find that we will represent forces in diagrams. So when we draw diagrams, force is usually represented by an arrow. We use an arrow. You might have realized when I drew this diagram here, I represented this arrow here is representing a force that is a pull and a force that is a push on this particular object. So it's very important to understand that the force will always be represented by an arrow. So we can draw an arrow. The arrow for force A is longer than the arrow for force B. So the implication is the fact that we are now saying that force A will be greater than force B. So two things: when we use an arrow, we are saying that the arrowhead is pointing in the direction, that is the direction part of force, and the length of the arrow will represent the magnitude of the force. So we can draw the arrowheads in any direction. So we can choose our force to act down. We can choose our force to act in any direction, diagonal. We can choose our force to act in any particular direction. Now let us get into the other concept as well that we need to discuss, which is the kinds of force. Like I mentioned earlier, we've got two kinds of force. The first one is what is called the contact force. Contact forces. So we are going to identify the contact forces that we have. Contact forces are basically forces that objects exert on each other when they touch or are connected to one another. Most of the forces that we are going to list here are contact forces. So I'll start by identifying the first contact force is what is called the applied force. So we've got the applied force, and the shortcut for applied force is Fn, Fa, or we can use T, especially when they are connected by a rope or a cable. An applied force is a push or a pull that is externally applied to an object. So any force that you can apply on an object, whether you are pushing it or whether you are pulling it, using a cable or pulling it using your hands, that force, that pulling or that pushing constitute an applied force. E.g., we can have a force that is applied by an engine on a car. That force is an applied force. So this is one of the forces that we will work with also in Newton's laws. So we can have a force. So when we apply a force, by pulling it, or we can apply a force by pushing it. So that we've got a pull or a push. Okay. That push or that pull will constitute an applied force. The other force that we have is what we call the normal force. The symbol for normal force is N, or we can use Fn. The normal force is defined as the force or component of a force which a surface exerts on an object with which it is in contact and which is perpendicular to the surface. Now we need to take note of a few terms here. One, we are saying that a normal force is a force which a surface exerts on an object. Okay, so a surface, it is the surface that is exerting the force. Secondly, that force is perpendicular to the surface. That force is perpendicular to the surface. So for example, when you are sitting on a chair, the surface of the chair is exerting a force on your body. So, and that force which the surface is exerting is what we call the normal force. And then the direction, this is speaking now to the direction of the force. Remember, we said that the normal force, a force is a vector. So in this case, when it says that the force is perpendicular to the surface, it means the direction between the angle between the surface and the force is always 90 degrees. So what we are saying here, there is always a 90-degree between the surface, there's a surface here, and the direction in which the force. If our object is on an incline and it's resting on a sloped surface like that, so our normal force, there is a surface, our surface is not horizontal, which means it is slanted at an angle. So what we need to realize as well is the fact that our normal force will be acting at an angle of 90 degrees to the surface as well. Okay, so we have 90 degrees here to the surface. So a normal force is a force or a component, any part of a force which a surface exerts on a surface, and that force is perpendicular to the surface. The next type of force that we have is the frictional force. The symbol for frictional force is a small letter F, or you can use the symbol F for force, and then FR, subscript FR, as frictional force. Now, the definition of frictional force is basically a force that opposes the motion of an object and which acts parallel to the surface. Two things that we should note here. One, the frictional force opposes the motion of an object. Secondly, the frictional force acts parallel to the surface. So what we need to understand is that when we have a frictional force acting on an object, if we have an object here, and when we are moving the object in any particular direction, let's say we are applying a force on that object, and we also have a force that is applied in the opposite direction. Okay, so that force is what we call the frictional force, and this one will be the direction of motion. Let's say we are applying a force here, so the object is moving to the right, so F is a frictional force because it is opposing the direction of force. Firstly. Secondly, the frictional force is always parallel to the surface. So if our object is moving on a surface, it is moving on a surface. Now, the frictional force is always parallel to that. It moves along. So it is always parallel to the surface and always acting opposite the direction of motion of the object. Now, under frictional force, we've got two types of force. One, we have what is called the static frictional force. The static frictional force, we use the symbol F with the subscript S there for static frictional force. And the definition of frictional force is as follows. So it is a force that opposes the tendency of motion of a stationary object relative to a surface. So what we are basically stating in this definition is the fact that static frictional force is a force that opposes the tendency of a motion of a stationary object. So two things again. One, it is a force that opposes the motion of an object. Secondly, that object is stationary, which means the object is not moving. We can just basically put it as follows: a force that keeps an object at rest. It is a force experienced when an individual tries to move a stationary object on a surface without triggering any relative motion between the body and the surface. If at some point you have tried to move an object, push an object with a force, but you feel there's a resistance to your pushing, the object is not actually moving because of the frictional force there. So that force that is keeping the object at rest is what we call the static frictional force. So the individual is trying to push the object, but the object is remaining at rest. So the static frictional force is basically the force that is keeping the object at rest. So you are pushing, but the object remains stationary. You can't quite move the object. So that force which is resisting, or that force which is experienced when an individual tries to move an object, but the object is not moving, is what we call static frictional force. So basically we are saying that there is a tendency to move the object. There's a tendency to move the object, but the object is not quite moving. Now there's also one thing that we can also add to the static frictional force is the fact that we have got an equation that we use, namely Fs is equal to mu S n, okay, where mu s is a coefficient of static frictional force. Static frictional force. Now the mu s is just a constant of proportionality, a proportion between the normal force and the frictional force. You'll find that here, if you just make, you have got fs, okay, you've got fs. I'm thinking of fk now because that's the other force that we are going to identify. So we have got fs is equal to mu sn. So when we divide by n, you'll find we have the equation mu s will be equal to f over n, which is the fs. So this is just a constant of proportionality, the proportion between the frictional force and the normal force. So mu s is the coefficient of static frictional force, and n represents the normal force. One thing that we need to understand also about the coefficient of static frictional force is the fact that it's a number between 0 and 1. So when the coefficient of static frictional force is 0, that means that there is no frictional force between the surface and the object, okay, but it grows bigger and bigger as the combination of the two surfaces, in other words, the friction experience between the two surfaces differs. The other force that we have under frictional force is what is called the kinetic frictional force. Symbol Fk. Kinetic frictional force is a force that opposes the motion of a moving object relative to a surface. You find two differences between the kinetic frictional force and the static frictional force. In the kinetic frictional force, we are saying that it is a force that opposes the motion of a moving object. So in this case, we have an object that is moving, and therefore there's a force that is opposing that particular movement. Whereas in the static frictional force, we have an object that is not moving, but it is stationary, and therefore there's a force that is opposing the tendency to get it to move. So those are the two striking differences between the kinetic frictional force and the static frictional force. Now we also have a formula for the kinetic frictional force, which is Fk is equal to mu kn, okay, where also the mu k represents what is called the coefficient of kinetic frictional force. And it is also a value that is you find between 0 and 1 basically. And there are no units for it. It is basically the proportion between the frictional force and the normal force. It is unique for every combination of two surfaces that are experiencing that particular frictional force. Now, a few things that we also need to take note here under the frictional force. Number one, frictional force is proportional to the normal force. Frictional force What this means is the fact that when the normal force increases, then the frictional force also increases, more like directly proportional. So the amount of frictional force experienced between two surfaces depends on the normal force. So that's one thing we also need to be aware of there. Secondly, the frictional force is independent of the area of contact. What this means is that when you take an object and you are moving it over a surface, the amount of frictional force experienced does not necessarily depend on the area, the size of the area that is in contact with the surface. And thirdly, the frictional force is also independent of the velocity of the motion of the object, simply meaning that the frictional force does not depend on the speed of the object or even the direction of the object. So we have listed one, the applied force, which is a contact force, and we have got the normal force, which is also a contact force. We have got the frictional force, we have got the static frictional force, and we have got the kinetic frictional force. So you realize why they are called contact forces, as we have defined earlier, is because these forces, they are experienced when the objects are exerting on each other a force and these objects are connected or they are touching. Now let's come to the other force, which is the non-contact forces. Under non-contact forces, we have got one major one. We have got a gravitational, which we are going to start with. That is the major one, gravitational force. The gravitational force, we use the letter W. We also call it the weight. So we use the symbols W or Fg for the gravitational force. And this is the force that we always experience, all of us here on Earth. So this is the force that the Earth exerts on any object on or near its surface. So we also are aware that gravitational force, we can calculate it using a formula. W for weight is equal to mg, where m represents the mass of the object. G is gravitational acceleration. G is gravitational acceleration, which is somehow constant, is given as a constant. That constant is given the value G is equal to 9.8 meters per second squared. So the other forces that we have under non-contact forces, I'll just list them here, but we will not cover them in detail. Two, we've got the magnetic forces. And three, we've got electrostatic forces. Electrostatic forces, will cover them in another topic, which is on electricity and magnetism. So as you realize, these forces, why they are called non-contact forces, because the objects, they do not touch each other. So these are forces experienced when the objects do not touch or are not connected to each other. Looking at the common contact forces we have, of course, we've got one non-contact force here, which is gravitational force, but most of the forces that we will get are the normal force, We have got an individual who is trying to push the cupboard to the left in this case. So we have the applied force, we have the normal force, which is the force which the surface is exerting on an object, and that force is perpendicular to the surface. We have got the frictional force, which is the force that is opposing the motion of an object, and that force is parallel to the surface. We have got the gravitational force. This is a non-contact force, which is the force that the earth is exerting on the object. Okay, so always the force is the earth is pulling the object towards its center. And then we have got the applied force, which is a push, or it can be a pull on the object with the attempt to move the object. So this diagram sort of summarizes some of the main forces that we experience in Newton's laws of motion. Lastly, we are going to mention what is called the free body diagram. Like I said in my introduction, that you will see that there is so much of writing here, definitions, and I hope you are coping well. It's important to know these forces and to know their implications, as you will find when we get into Newton's laws of motion. We are going to mention these forces, so it's very important for us to know them. That's the reason why we have to cover them in this tutorial. So this is just but a series of tutorials that we are going to have on this section of mechanics. Now, with regards to free body diagram, a free body diagram is a diagram that shows the relative magnitudes. Magnitude simply refers to the sizes. So it's a diagram that shows us the sizes and directions of the forces. Take note of those two areas. It shows us the magnitudes as well as the directions of the forces acting on a body or particle. Remember, in physics, we have got the three terms that we use synonymously. We have got a body. So a car can be referred to as a body, or it can be referred to as a particle, or it can be referred to as an object. So we will see that sometimes we use the term body, or we use particle, or we use object. We use these terms synonymously. So a free body diagram is simply a diagram that is showing all the forces that are acting on an object. That's what we are saying in this definition. And what we are showing are the magnitude, the relative, the comparative sizes of those forces, as well as the directions of the objects, or directions of the forces that are acting on the object. Now, one thing that we need to also take note when we are drawing a free body diagram is the fact that in a free body diagram, the object is represented by a dot. And all the forces that act on the object are indicated by arrows pointing away from the object. So a free body diagram, this is a guideline of how we should draw a free body diagram. We have to represent the object by a dot, and all the forces that are acting on the object are represented by arrows that are pointing away from that particular object. Let's take an example of our man who is pushing a cupboard. We have a surface here. We have gravitational force. We have the normal force. Let's say we have the frictional force, and we have the applied force. We have the weight, we have the frictional force, we have the applied force, and we have the normal force. So these are the forces that we have in this diagram. Now let's say now we want to represent this in the form of a free body diagram. So what we have to draw the free body diagram according to this guideline is we have to show all the forces acting on the object, and then we are going to draw a force that is representing the weight or the gravitational force, and that force should be pointing away from the dot. So I'll have a force, I have to draw a force acting downward, which is the weight, use a straight line, and there is frictional force which is acting to our right, so we represent the frictional force acting in that direction, which is F. We have a normal force acting upward, so also show the normal force. Okay. And then we'll show the applied force acting in that direction. Okay, the applied force. So this diagram would represent the free body diagram. So you don't have necessarily to draw the picture, the whole picture of the diagram. When you draw the whole picture, you are sort of referring to what is called a force diagram. But most of the questions do require to draw a free body diagram. So take note here, the object, the whole system, the object we represent it by a dot, which is the cardboard, and we represent the forces that are acting on the object by arrows that are pointing away from the object. Now here I'm not very particular about the magnitudes. Okay, you could make maybe the frictional force a little bit smaller, just to show the relative magnitude sizes of those forces. But as for the weight and the normal force, these two will have equal lengths. The arrows will have equal lengths, because in this particular case, the normal force will be equal to the gravitational force because they are in equilibrium and they are balanced. In summary, we have got the definitions of one, force. What is a force? Okay, and we also said force is a push or a pull. And secondly, we identified the kinds of force. We have got the applied force, the normal force, frictional force, static frictional force, kinetic frictional force, and the gravitational force. We also went on to cover the free body diagram, which is basically a diagram that we are drawing showing all the forces that are acting on an object. And the object is represented by a dot, and the forces are represented by arrows that are pointing away from the object. Thank you for watching. We'll see you next time. Bye.